polar form. All right, polar form. So if I give you a complex number, a plus bi, and I have to draw it in this complex or this complex plane. Notice that this is just your real axis and this is your imaginary axis. On the real part, we have just a. So you see, this is a for your real part. Your imaginary part there is b. So on the your usual y direction in this part, we call the imaginary axis, you have b. All right. If you resolve components, this hypotenuse is just given by r. All right. And what is r? From Pythagoras theorem, r is going to be the square root of the squares of these two, right? So you can always treat r as the modulus, all right, or the absolute value. So r there is the modulus. If you resolve components, a is just r cos theta and b is r sin theta. In polar form, we get if z equals to a plus bi, then you have that z is r cos theta, r sin theta times I. Factor out the r because you can see the r is common. All right, take out the r. You just have r into cos theta plus I sin theta. This is what we call polar form. So if I give you any complex number and say write this in polar form, you should be able to do this. All right. Obviously, where r is just the modulus, which is square root of a squared plus b squared, and tan of theta. So in case you want to find theta, tan of theta is just b over a. So it's imaginary part over real part, and it also includes the sign, meaning that if this changes to minus, then you're going to have, in this case, minus b over a. All right. Let's look at example 4. They ask us to write the following numbers in polar form. Okay, these are the steps that you need to you must use if you want to get your answer to be correct. All right. First thing is, because the real and imaginary part is positive, you know it lies in the first quadrant. All right. So look at what I've done. I simply plot a little argon diagram there. We call this argon diagram. And I show that 1 plus I actually lies in the first quadrant. And the hypotenuse is root of 2. How do I get that? You solve for r. R is just square root of real part squared plus imaginary part squared. You see it's root 2. That's how we got this root 2 there. And then how do I get this power over 4? You use the fact that if tan theta is imaginary part of a real part, therefore theta is tan inverse of imaginary part of a real part, which is just tan inverse of 1 over 1, which is power over 4. Again, you see it works, it's power over 4 because it lies in the first quadrant. Therefore, in polar form, we say is r, which is modulus, so root of 2, cos of theta plus I sine of theta. Please don't simplify this, because if you try to evaluate cos of theta and sine, you just get back to this original stuff. All right. So leave it in that form. That's in polar form. Now, the reason why this diagram is so critical, you're going to see why. Look at example B now. All right. Example B, if we need to draw our argon diagram, notice that this lies actually in the fourth quadrant. All right. Why? Because your I there is negative. So in other words, if we compare this to the XY plane with the usual X and this side have been Y, notice that your X is root of 3 is positive. So treat the real line as your X and your imaginary line as your Y. Notice that this minus, so your Y part is negative, means it has to be here in the fourth quadrant. All right. And if you remember, well, I said that when theta is negative, it means you measuring clockwise. All right. Hence the reason why theta there is measured clockwise. All right. Because the only way I can measure the angle in my fourth quadrant is if I'm going clockwise. All right. I'm going to show you again. I'm going to demonstrate why we have these values. So for r, r is just square root of real part plus imaginary part. Remember, the imaginary part is negative, so you see minus 1 squared. It just gives you 2, and theta will be tan inverse of minus 1 over root 3. So the imaginary part, which is minus 1 over the real part, which is root of 3. And if you do that, you get something like this, minus pi over 6. minus pi over 6, if you notice it, because it's negative, when theta is negative, we say we measure in the clockwise direction. So I'm going to start there, and you see why I'm going the clockwise direction. In this other one, we're going in the counterclockwise direction because theta is positive. All right. And another student might choose to say, but in the fourth quadrant, I can get a different value for theta, which is 2 pi minus my reference angle, which is pi over 6. The answer is yes, that is acceptable, but you must keep in mind that that cos is positive there, while sine is negative there. All right. The reason why I'm mentioning these other possibilities because I actually asked that in the past. All right. So if you don't see minus pi over 6 and you see some other value, just consider the fact that that in the fourth quadrant, I can still use 2 pi minus reference angle. All right. And we know that for the second quadrant, we can use pi minus reference angle. In the third quadrant, we can use pi plus reference angle. So you must remember those other possibilities. So it's not always the case that you're going to see me giving you this kind of answer in case it's a multiple choice. All right, you might see some different answers. So you need to consider the other possibilities. All right. If everyone is happy, let's move on. Let's look at multiplication and division. All right, multiplication and division. They say if Z1 is R1, remember this has already been given in polar form. So I'm trying to multiply two complex numbers that are already given in polar form. Guys, pay attention for the multiplication. When multiplying two complex numbers, and I ask you, I want the result of this multiplication in polar form. You have two ways of doing it. You can start by multiplying them and then convert your final answer to polar form, or you convert both of them first to polar form, and then you apply this formula here. All right, and how does the formula work? If you say Z1 times Z2 means you start by just multiplying the arrows. So the arrows multiply, so R1 times R2. And then the argument, remember we call this theta the argument, you simply add them up. All right, so you have cos of theta 1 plus theta 2, I sine theta 1 plus theta 2. All right, and take note, if one of them is negative, let's say theta 2 is negative, then obviously here you're going to have theta 1 minus, because if you say plus minus, it's actually a minus. Now for division, see how it works. Again, you see R1 over R2. Remember, those are the modulus. And then you say cos, now you subtract it. So when I'm multiplying, I'm adding the theta values. When I'm dividing, I'm subtracting the theta values. All right. But for this to work, both complex numbers need to be in polar form. All right. And then another formula says if Z is this in polar form, 1 over Z. All right. 1 over Z will just be 1 over R. 1 over R cos of theta minus I sine of theta. You also need to remember this. Remember, 1 over Z is almost like the reciprocal of a complex number. All right. If everyone is happy with this formula, let's see how do we apply this formula. They say find the product of the complex number 1 plus I plus root 3 minus I in polar form. All right. So the method you see there strictly uses the formula that I gave you. But like I said earlier, you're more than welcome to start by multiplying them out in this form. We call them like in Cartesian form. And then you convert your final answer to polar form. It will still work. All right. But I would say for the easiest way of doing it will be find the moduluses, which is just R1 times R1, R2, find theta 1 and theta 2. The good part is that these two are examples that we've already seen before. So we already know that R1 is 2, R2 is 2, theta 1 is power 4, theta 2 is minus power 6. So we're just using this one from the previous examples. Now the product of the two complex numbers, remember you need to multiply the modulus, and then you need to add your theta value. So you have 2 times root 2 cos, you see, that's exactly what I actually mentioned before, that what happened if one of them is negative. So it's still plus, but remember plus minus is minus. All right, that's why you see it end up just being a minus sign there. And if you do that, you have 2 root 2 cos of pi over 12 I sine pi over 12. Live in polar form. Don't try to punch this in a calculator and give me some decimal answer. If you do that, I'll assume that you cheated. Calculators are not allowed. All right. Let's look at De Moivre's. De Moivre's theorem, guys. Everything that we're doing here is something that I will test you on. So if you feel like a section is not important to you, all I can tell you is good luck. They're all important. You need to know them. De Moivre's, we use De Moivre's to find a complex number raised to some power n. But keep in mind, n has to be a positive integer. All right. De Moivre's only work, guys, pay attention. De Moivre's work if your complex number has been transformed to polar form. Only then can you apply De Moivre's. So De Moivre's, the first step is convert that complex number to polar form and then apply this formula here. This is the formula for De Moivre's. What does it say? It says that if I have r into cos theta plus I sin theta all raised to the power n, all I need to do is to take r raised to the power n, which is what I do here. And then where I see theta, I just need to multiply them by n. So you see they have n theta, I sin n theta. Raise r to the power n, multiply the theta value by n. All right. Now I say find this to the power of 10. All right. How do you do that? First step, polar form. Very important, polar form. And the trick when converting to polar form is please do yourself a favor and draw this diagram here. All right. I understand both of them are positive, so you can see it's in the first quadrant, so it's easy to compute this. Sometimes or most of the time, one of them would probably be negative, because if I make both of them be positive, it becomes too obvious. Everyone is just gonna do it quickly. But if I make one of the negative, it changes everything. It means you need to start by plotting this to see what quadrant it lies in. All right. Now that you've done that, let's see, arrow there, we can compute arrow, obviously. You just take the square root of the real part squared plus the imaginary part squared. And if you do that, you have 1 over root 2, which is just the same as square root 2 over 2. Tan theta says is the imaginary part divided by the real part. Therefore, theta just becomes tan inverse of 1. Again, tan inverse of 1 is pi over 4. Pi over 4 is accepted because we're dealing with the first quadrant. You see, that's the reason why pi over 4 is accepted. If it was in the second quadrant, and then you give me something like pi over 4, I'll just laugh. All right, it means you actually know what to do. Pi over 4 cannot exist in the second quadrant. All right, so pi over 4 because it is in the first quadrant. De Moivre's says that write this in polar form, and then you just need to take r raised to the power n, so it becomes root 2 over 2 to the power n. Cos of n, remember your n is actually 10. So what I'm doing, I'm actually applying this formula here. All right, so cos of n times theta, so it's 10 times pi over 4 plus I sine 10 times pi over 4. If you simplify, you get this. I see most of the time I test, people don't simplify this piece here. They think, oh, this number is too big for me to simplify. You have to simplify as much as possible, right? Root 2 to the power 10 it just becomes 2 to the power 5. 2 to the power 5 divided by 2 to the power 10 is just 1 over 32. All right. You have to simplify this as much as possible. And these are things that you can simplify without a calculator. Somebody is going to say, how do I simplify this without a calculator? Okay, I'll do you a favor and I'll show you how to do that now. All right. So I have square root 2 and I want to raise this to the power 10. All right. The lazy way of doing it, or in mathematics, we will say the crazy way of doing it, is multiplying root 2 10 times, which is too much work. It's almost like you didn't do any maths at all. All right. For a terrible person, they're going to multiply root 2 10 times. For someone who's very smart, they know that root 2 simply means 2 to the power half. All right. Remember, square root simply means I'm raising something to the power half. All right. And if you do that, you see, now I just need to multiply the powers out. 2 goes there, 1, 2 goes there, 5. I end up with what? 2 to the power 5. It's as easy as that. All right. So that is how you can simplify square root of a number raised to some power. All right. If everyone is happy, let's see if, we now go to the roots of a complex number. Guys, there's no way you're going to run away from the marvels and the roots of a complex number, right? Roots of a complex number is a must. You must know this, all right? And this first example is so critical, all right? When I say so critical, it's going to form a good foundation or a basis for what you're going to see in your semester test. So let Z be this complex number in polar form. You see, again, when we talk of the marvels, we say polar form. We talk of roots of complex number, we still want your Z to be in polar form. So let Z equals to represent this complex number in polar form. And I say let N be a positive integer. You see, N has to be some positive integer. And then Z has N distinct N roots. And these are the N roots, all right? We just call them W subscript K, where K is from 0 all the way to N minus 1. If you remember well, you want N root, all right? The fact that your K always starts from 0, you can't stop at N. If you start from 0, you need to stop at N minus 1, all right? Because this 0 is an extra term, so you need to stop at N minus 1. And how do you get the root? You just take arrow to the power 1 over N. So if I ask you for square root, it means your N there is 2. If I ask you for cube root, your N there is actually 3. You say theta plus 2k pi over N plus I sine theta plus 2k pi over N. It's just a formula I need to remember, guys. It's a must. And the good part is because it's more or less an open book test now, no one should say they have forgotten the formulas for root of a complex number, right? So everyone should be able to get full mark when it comes to this. Now, why do people lose marks when it comes to number? Apparently, a lot of you are going to lose marks. I'm going to explain now, all right? They say find the sixth root, all right? Actually, I'm just asking for find all the 6 roots, all right? The 6 roots, and I want you to find all of them. And remember, when I talk of 6 roots, I'm talking about this. So we're looking at Z to the power 1 over 6, all right? So Z to the power 1 over 6. So the 6th root, all right, of Z equals to minus 8. And then I say graph these roots in the complex plane. So you have to show me what all 6 of them are, those 6 roots are, and then you need to graph them on a complex plane. This is a very nice one. The first thing is Z equals to minus 8. Somebody will say this doesn't look like a complex number. It is. It's just a complex number that has only a real part because the imaginary part is 0. All right. Another way of writing this is Z equals to minus 8 plus 0i. There's no imaginary part. It doesn't mean it's not a complex number. Okay, we solve for r there is 8. N is equal to 6. Remember, N equals to 6 because we're looking for 6 roots. Now, very important. For you to find your theta, you go back to the good practice that I said. You must always plot this on your complex plane. And how does that work? If Z is minus 8, it means the imaginary part is 0, right? Minus 8, you're sitting somewhere there. So on the real line, you're somewhere there on the other side of 0. And I is 0. Again, I'm on that line, all right? And if you compute your theta, look at that. It's just pi, all right? Your theta there is just pi. So in this case, theta is tan inverse of 0. Remember, imaginary part that there's no imaginary part, so we say 0 over minus 8. And tan inverse of 0 is just equals to pi, all right? And this pi, you see, I got it from this diagram, right? Because I know the only way to move from this side all the way to this line is 180 degrees, is pi, right? Then the next thing is plug and play. If you know what r is, you know what n is, you know what theta is, you just go to this formula and then you do plug and play. You start with what? You start with W, W subscript 0, W subscript 1, all the way to W subscript 5. Guys, you need to watch out. If n equals to 6, it means you're doing from W subscript 0 all the way to W subscript 5. All right, those are 6 numbers. If you go all the way to W subscript 6, it means you're looking for 7 root now. All right, it means you're adding something on top of what I actually asked you, which is a disaster. You don't want to do that. All right, let's see. So W0, and the good part about this question is that this value here, you can actually simplify them. So W0, we say r to the power 1 over n. Remember, n is 6. So it's 8 to the power 1 over 6. cos of, you need to simplify this. So theta there is pi. Your k there, remember your k there is 0. K is 0. Your n is 6. So you agree, it's just pi over 6, since this whole term is going to fall off. Hence, the reason why you have this. And if you simplify, 8 to the power 1 over 6 is just root of 2. All right. Some of you are asking, but how is that possible that 8 to the power 1 over 6 is actually equals to root of 2? Well, 8 itself is just 2 to the power 3. All right. And if you multiply that power there by 1 over 6, what do you get? You just get 2 to the power half. And what does it mean to raise something to the power half? It just means square root. Hence, we have root of 2. So I expect you guys to simplify. Like I mentioned again, you need to simplify these values here. Always simplify as much as possible. Root of 2, if you take cos of this plus sine of it, you just get root of 3 over 2. And then if you take W1, W2, and so on, you see I stop at W5. And there you go. And if you simplify those, you get these values here, all right? You don't stop here because I say you need to plot this on your complex plane, all right? On your complex plane, what do you get? Notice it, W0 lies somewhere in the first quadrant, so it lies somewhere there, all right? And W1, you only have the imaginary part, there's no real part. The only way that is true is if it lies on this line. You see why it's there. And then W2, you see the real part is now negative. Real part is negative, means you somewhere now on the left hand side. And W3, you're sitting on this line. And so on. So you keep going. And you notice it forms a circle. All right, it forms a circle. Guys, only plot this complex plane if I ask you to plot. Because some people do a lot of cram work and I say find the roots. They just go ahead and find roots and start plotting on the complex plane. All right. If I say find the fifth root or the sixth root, just give me the roots. All right. Just give me the root. Don't go ahead and plot it on the complex plane. Now B1. The reason I'm saying B1, in a test, it's possible that when I ask you for these roots, you can actually simplify these values here without using a calculator. The minute you start giving me stuff here in decimals, I assume that you've used a calculator, right? You're going to lose marks. So if you have some funny value, let's say cos of pi over 36, for example, just leave it in polar form, all right? So my best advice is only simplify these roots if you can do it without a calculator, because it's very possible I can do these values. I can find these values without using a calculator. All right. But if you have some funny values that gives you decimals, in other words, they're not spatial angles, then please don't give me decimal value because calculators are not allowed. All right. So you actually stop here. Now, what happened if I ask you this question, then you choose to stop here. So you give me all your answers in polar form, and then you choose to not simplify them. All right. If it's, let's say, for example, if it's 6 marks, obviously you're going to lose, I would say about 1.5 marks or 2. All right. So if you can simplify them, you should be able to simplify them. But if you notice that your theta value is definitely cos or sine of that gives you some decimal values, please just ignore it. Just leave it in polar form. All right. For example, if you have some funny values like, let's say, pi over, let's say, 43, right? Obviously, you can, this is not a spatial angle, pi over 43. So you can go ahead and punch in a calculator and say 0.4567 plus 0.4567i. I will say that cheating, you use a calculator, right? If everyone is happy, do more examples. Please do more examples. Do more examples when it comes to 1, writing a complex number in polar form. 2, simplifying complex number in the form a plus b. I've already done an example where I applied the concept of complex conjugate. All right. 3, be able to multiply complex numbers given in polar form and be able to divide complex numbers given in polar form. And next, you need to be able to apply De Moivre's The marvel says I raise a complex number to some power, all right, where that power has to be n being a positive integer. So that power n has to be a positive integer. The marvels. Make sure you do more examples. And then root of a complex number, which is a guarantee you're going to see on our big day. You also need to be able to find a root of a complex number. And what did I say about the roots? There's a step that if you get it wrong, then everything else is wrong. All right. The first step, guys, you need to pay attention, is this whole step here. If you get this step wrong, your theta is going to be wrong, and then all your roots are going to be wrong. So if it's 6 marks, you basically have a mark for maybe having arrow, and maybe for sketching a diagram, maybe I'll give you half mark, and maybe for method mark for knowing the formula. You get 2 out of 6. All right. So if your theta is wrong, everything else is wrong. Most of the time, you guys get arrow to be correct. I haven't seen anyone that got arrow wrong since I started lecturing, but most of the time, you guys get theta to be wrong. Why? Because you don't start by plotting it here on a complex plane. Always plot on a complex plane. See what quadrant it lies in. See if it lies on a line or it lies in one of the quadrants, and then measure either clockwise or anti-clockwise. See what the correct theta value is. All right. That's basically for my side. It's exactly 6 because what is coming next is just homework problems. Do the homework problems. You see, the homework problem covers everything that I want you guys to know. All right. So I said evaluate each and write your answer in the form A plus BI. So you need to do that. You need to do ABC. You need to find all solutions to that equations. You should be able to apply the marvels for question 3. And then question 4, obviously we've already done. And if you notice in question 4, I insist that you also sketch the roots in a complex plane. So see if you can